Hello, this is Numbers lesson 7.2. In this, I will discuss the questions based on the concepts I discussed in the previous lesson. Now, first of all, this is a number, big number I have taken. Now we have to find the total factors, even, odd, perfect square. We will find all kind of things. Can I say that straight away I can apply the perfect total factor formula? No, because this is 10 square. This is not the prime factorization. This is not prime factorization, because 10 is not a prime number. So first we will convert this into prime factorization. 10 is what? 10 into 10 is 2 into 5 square. Can I say this is equals to 2 square into 5 square. So finally n will become how much? 2 square into 2 power 7, this become 2 power 9. 3 power 5 will be as it is. 5 power 4 into 5 power 2, because 10 square was in multiplication. This will become 5 power 6, 7 cube, and that will be my number. This is the number 2 power 9, 3 power 5, 5 power 6 into 7 cube. Now this is a number we need to find all kinds of things we discussed in the previous lesson. For example, total factors would be we add 1 and multiply with them. So 9 plus 1, 10 into 6 into 7 into 4. We are just adding 1 to the powers. 2 power was 9, 9 plus 1, 10. 3 power was 5, 5 plus 1, 6. 5 power 6, 6 plus 1, 7 into 4. This is 60 into 28. 6 8s are 48, 6 to the 12. 1680 will be total factors of n. Now we need to find the next is odd factors. Now how to find the odd factors? Again, if you see, take on the 2 side, 2 power 0 will be there, because 2 power 1, 2 and so on multiplied with any power of 3 will give me a even factor. So on the 2 side I will take 2 power 0. On the 3 side it will be 3 power 0, 3 power 1, 3 power 2, 3 power 3, 3 power 4, 3 power 5. No need to write in the exam, only just I am writing in order to explain you. 5 power 0 to 5 power 6, 7 power 0 to 7 power 3, all will be there. If you multiply 2 power 0 with any of these numbers, the product will always be a odd. This and this, the product will always be odd. So one number from this side can be taken in one ways. In this side, how many numbers are there? 6 numbers are there. 3 power 0 to 3 power 5. And in this side 7 numbers are there. In this side 4 numbers are there. So total product odd factors are 6 into 7 into 4. That is 6 into 28. 168 odd factors will be there. So simply in odd factors, what we have to do, only have to take 2 power 0. 3 power 0 to 3 power 5 will be as it is. So total it will be 6 ways we can select one number. Now even factors, no need to calculate the even factors. Total factors minus odd factors will be even factors. So 1680 minus 168, that will be your even factors. No need to calculate. Always first calculate the odd factors, then you can easily calculate the even factors. Total minus odd will be even. 1512 will be your answer. That is total number of even factors. Now what are perfect square factors of this? Now you know the perfect square. What is the meaning of perfect square factor? Perfect square factors are those factors which are factors of n as well as perfect square. We know that in perfect square the power of every prime number is even. It could be 0 also. So 2 power 0, 2 square, 2 power 4, 2 power 6 from the 2 side, because the number was, our number was 2 power 9, so 2 power 8 will also come. So this when multiplied with any power of, even power of 3 will make a perfect square factor. From 3 side we will take 3 power 0, 3 square, 3 power 4. From 5 side we will take 5 power 0, 5 power 2, 5 power 4, 5 power 6. And from 7 side 7 power 0, 7 power 2. So if you multiplied this, any number from, one number from 2 side, one number from 3 side, one number from 5 side and one number from 7 side, if you multiply it, this will be a perfect square. 2 power 4 into 3 power, for example, I'm just taking an example, 2 power 4 into 3 square into 5 square into 7 square. Now this number is a factor of n as well as a perfect square. Another case, I'm taking 2 power 8 into this and into this. So 2 power 8 into 3 power 4 into 5 power 4 into 7 power 0. This number is a factor of n as well as perfect square. So for perfect square, we have to take even powers of prime numbers and then multiply it and make the how many possible combinations are there. So in this case, how many combinations there? One number from this side. So 2 power 0 to 8, we can take 1, 2, 3, 4, 5. We can take select one number from this side in 5 ways. One number from this side in 3 ways. One number from this side in 4 ways, because we can select 5 power 0 or 5 power 2 or 5 power 4 or 5 power 6 into one number from this side in 2 ways. So 5 3s are 15, 4s are 16 into 2, 120 factors of n will be a perfect square. 5 3s are 15, 4s are 16 into 2, 120 factors, and those will be perfect square. What about perfect cube? How to find the perfect cube factor? Again, 2 power 0, 2 cube, 2 power 6 and 2 power 9 will be there. Same way from 3 side, 3 power 0, 3 power 3. 3 power 6 is not there because our prime factorization number is n is equals to 2 power 9 is there, 3 power 5, 5 power 6 into 7 cube. This is our number. So from 3 side, this would be 3 power 3 only. From side 5 power 0, 5 cube and 5 power 6 will be there, and 7 power 0 and 7 cube will be there. Now if you take any combination and multiply it, you will always get a perfect cube. 2 power 6 into this, this is also a perfect cube. This one, 2 power 0 into 3 power 0 into 5 power 0 into 7 power 0, this is also a perfect cube. So how many ways we can make this? One number from this side in 4 ways, into one number from this side in 2 ways, into one number from this side in 3 ways, into one number from this side in 2 ways. So you will get 4 2s are 8, 3s are 24 into 2, 48 would be your total. You can say that those factors will be there. That will be perfect cubes factor of n will be there. So our n was this. Now next is prime factors, PF. Prime factors of n would be how much? Can I say 2, 3, 5, 7? These are only 4 prime numbers. So prime factors would be 4. Again, different kind of questions can come. Factors which are multiple of let's say 12. Factors of n which are multiple of 12. How we will find this? You can take this is the prime factorization of n. 2 power 9 into 3 power 5 into 5 power 6 into 7 cube. I will take 12 common. So can I say 12 is what? 12 is 4 into 3, that is 2 square into 3 power 1. I will take this common. 2 square into 3 power 1 I will take common. Rest is what? 2 power 7, 3 power 4, 5 power 6, 7 power cube. That is left. Now we will only calculate the factors of this. Total factors of this, let's say n1. This is n1 number. And these all factors are multiplied by 12. So 12 into this. So total factors of n will be the factors of n which are multiple of 12. Because every factor of n1 multiplied by 12 will become multiple of 12. And that is what we need to calculate. So this total factor of this would be how much? 8 into 5 into 7 into 4. We are just adding 1 to the power. So 8 5s are 40 into 28. This is 4 8s are 32, 4 2s are 8, 3 11. 1 1 2 0 will be the factors which are multiple of 12. Factors of n which are multiple of 12. Simply we have to take 12 common and number will be, let's say this number is n1. So every factor of n1 multiplied by 12 will become the multiple of 12. Next is number of ways of resolving 144 as a product of two factor. Now I told you that if we calculate total factor 144, this is a perfect square, this is 12 square, or you can say that is 16 into 9, 2 power 4 into 3 cube. Total factor of this would be how much? 5 into 3, 15 factors of there of 144. Now how many ways we can write 144 as a product of two factors? I told you first and last factors will give as product as 144. So 7 pairs we can straight away make. 7 pairs, first last, second last, third last. So 7 pairs will be there, and one number will be left in between. One number will be left, and that number will be the square root of n. Square root of number, that is in this case 144 square root. So 12 will be left in between. So one way would be, one pair would be 12 into 12, because we want to write 144 as a product of two factors. So 7 pair plus 1 pair, this would be how much? 8 ways of writing 144 as a product of two factors. I am just explaining in a detailed manner. In exam you straight have to answer. So for example 1, 2, 3, 4, 6, 8, 9, 12, 16, 18, then there is 24, 36, 48, 72 and 144. I think these are 15. 1, 2, 3, 4, 4, 4, 8. Yes, these are the 15 factors of 144. Now you can see that first into last you will get product as 144. Second last, 2 into 72 you will get product as 44. 3 into 48, 36 into 6, 8, no, 36 into 4, sorry, 36 into 4, 6 into 24, 18 into 8, 9 into 16. The only thing that left is 12, that number, because total factors are 15, one number will be left in between. So 7 pairs straight away you can find, first last, second last, straight away by common sense 15 numbers are there. So 40 numbers we can make 7 pairs, all of whose product will be 144. So the last pair could be 12 into 12. If the question comes like this, number of ways of writing 144 as a product of two different or distinct factors, then our answer will be 7 ways, because 12 into 12 will not be counted in this. So that's the difference. When this case will be there only when the number is a perfect square. Number of ways of writing 144 as a product of two different factors, because 12 into 12 although will make 144 and both of these are factors, but they are not distinct. So distinct answer would be 7. Otherwise your answer would be 8 ways. And what about the product? Product of all factors AF, product of all factors. Now we know that there were 15 factors, total factors were 15. So first into last, second into second last, the product will be number 144. So 7 pairs will be there, first into last, second last, and one number will be left in between. So 7 pairs, each pair's product will be 144. So 144 into 7 power 7, because first into last, second into second last, each will be make 144. So 144 will become 7 times, and one number I told you, that number will be the square root. So that is 12, square root of number. So answer is 12 power 2 into 7 into 12 power 1. So 12 power 15 will be the product of all factors of 144. So in this way you can solve these kind of questions. So that was all about numbers lesson 7.2. In this I have discussed the very important question based on factor related concepts. Thank you.